Good morning, good afternoon, or good evening. This is going to be a full paper work through of the June 2019 2HR paper. As much as possible, I have not looked at this paper before, so you'll be seeing the first reactions, as well as hopefully giving any hints or tips for attempting this paper yourself. As always, whenever you start to sit down to a paper, make sure you've got all the equipment close by, your calculator, protractor, compass, etc. Without further ado, let's get straight into it. As always, page 2 is your formula sheet. It's worth knowing exactly what's on this sheet so you can refer back to it and aid our memory for those. Straight into question 1 then, a inequality question. Write down the inequality. -3 is the special number. It's an empty circle, and we're going off to the right. The empty circle means we're greater than, not greater than or equal to. Nice easy first mark. Solve the inequality. Remembering inequality, solve exactly the same as equations. If you're not timesing or dividing by a negative number, first going to subtract y from both sides. Add the 13, and finally divide by the 3. So no, it's exactly the same as solving the equations, same symbol all the way down. I didn't have to divide by a negative, so I don't need to make any changes there. Question 2 is a show that. Always be careful with show that. You need to put every relevant line of working in. First thing I'm going to do is turn these improper. Take the bottom, times by the big number, add on the number on the top, and again times and add. I've turned them both improper. Now I need a common denominator. 12 is going to be my choice, also the obvious choice being in the answer as well. To get from thirds to 12, so I times top and bottom by 4. And to get from quarters to 12, so I times by 3. So that's giving me 35 over 12. A little bit of mental arithmetic. 12 goes into 35 twice, even behind 11 out of 12. Because you don't have to do that question entirely mentally. You can cheat on steps with your calculator as long as you write down every relevant step. In particular, if you don't write down that 35 over 12, you're likely to drop at least 1 mark. Complete the table of values. Here I am going to jump to the calculator. Now you should be very careful whenever you sub in a negative number, that negative number itself should be in a bracket. So in particular, what I've typed in for that first section is as, with the correct sign in between, was this. Notice that -1 is inside a bracket, particularly the squared is on the outside. Otherwise, your calculator will give you the wrong answer. Putting in 1 as well. Comes out as 5. Putting in 4. Minus 4 squared gives me 5 again. And you should be able to notice some symmetry here. If you're particularly ahead of the game, you'll notice that this is quadratic in nature. Quadratics have that line of symmetry. So this set of coordinates have a line of symmetry. Now let's plot them carefully. -1, -5, 0, 1, 1, 5. 2, 7, 3, 7, and back the other way, 4, 5, 5, 1, and 7, and 6, sorry, -5. Now your curve will look a lot better than mine on pen and paper. It's a little easier to make these, and you can see my curve went miles off at the end there, make these a lot nicer. Do make sure that the curve goes all the way across the whole picture. You don't need to stop there. But the key point is here that this top section is not flat. If you draw that flat, that's often written in as a lost mark, particularly in the mark scheme. So make sure that you do have that little bump going above that 7 level. Question 4, similarity. Similarity for me is always to find the scale factor first. I always do big divided by small. 40 divided by 16 simplifies down to 2.5. So to me, that's telling me I'm multiplying by 2.5, going from the small one to the big one. And we want the length of DE 12 times 2.5. Of course, tie that into your calculator to get your answer of 30 units from the answer line. We're happy already. The area of DEF, so this time we're going backwards, is that. Well, we now need the area scale factor, which is that linear scale factor squared. So 6.25 is the number I'm using. I'm also going backwards. Oh no, I've misread the question entirely. This isn't similarity anymore. We are just converting the area of DEF into meters squared. We're not actually doing anything with ABC at all. So you can ignore those last comments. Now, from centimeters to meters, we normally would divide by 100 because it's meters squared, and centimeters squared we divide by 100 squared. 525 divided by 100 squared as a decimal is 0.0525. And again, units on the answer line, I don't need to remember to put them in. Factorize, we look for two numbers which multiply to negative 36 and add to negative 5. Think about my products that go to 36. 136 doesn't work, 218 doesn't, 312 doesn't, 49 might. And yes, if I use negative 9 and positive 4, that does work. So straight into my brackets, x plus 4, x minus 9. And you should, as part of your checking process, expand that out with FOIL and see if it does indeed get back to where we started. Question 6. We have some ice lollies. This looks like a probability question. The flavour of each lolly is banana, strawberry, mint or chocolate. We're taking one at random. We have some of the data but not all of it. We want the probability of strawberry or mint. Well, mint is missing at the moment, and the one key fact you need to remember here is probabilities add up to 1. So if we get rid of all of the probabilities we have already, subtract that from 1, we will hopefully get, well, we will get the correct answer, 0.21. So I'm going to put that into the table. But we wanted the probability of strawberry or mint. Well, now we just add those together. 0.32 plus 0.21. And our answer, 0.55. Nope, not 0.55. Mental arithmetic has failed me there. 0.53. And you can check that banana and chocolate should be the leftover probability, 0.47, which indeed it is. Question 7. We are playing 55 games, and the ratio of win, draw, loss is as shown. Well, this is just a fancy share in a ratio question. We have 11 parts in total, 6, 3 and 2, and that makes 55 games. So one part is 5 games. We want to know how many more games that they won than they lost. Well, we have 4 parts more, and 4 parts was 20 games. So there are 20 more games that we won than lost. Of course, you could work out how many games they actually won, which would have been 30, 15 and 10, and then done the difference afterwards. Either way works. Question 8. Find the highest common factor of these numbers. Now this is a sneaky question because it's given in the prime factor form already, which can make it easier or can make it harder. I quite like it in this form because highest common factor, all we need to do is look at each prime in turn and pick how many we are allowed. So let's look at the 3's. A has 3 squared, B has 3 to the 4. The common factor can only have 3 squared. Otherwise it won't be a factor of A. And we want the biggest as possible, so we want to include as much as possible. The 5's, this time we're allowed 5 cubed. Any higher, we won't be a factor of B. There is also a 7 in common, but nothing else. Now the question didn't say give it in prime factor form, so I'm going to calculator that out. 7,875. Other way to do that question quite easily is via the Venn diagram. Draw your 2 circles for the Venns. We now want the least common multiple, and again in this form it's really nice. The least common multiple, well, it has to be a multiple of both, so every number has to exist. Looking at the 3's this time, we have to have 3 to the power of 4, otherwise we won't be a multiple of B. But we want to be as small as possible, so that's the smallest that we could have. The 5's, we have to have 5 to the 4 to be a multiple of A, we have to have the 7 to be a multiple of either, and we have to have the 11 to be a multiple of B. Again, typing that into my calculator, we're going to get a ridiculously large number. 3898125, 3,898,125. And if you do think of your other methods of HCF and LCM, they would have been completely unreasonable if you turned A and B back into normal numbers. Question 9, write that thing in standard form. Well, the number between 1 and 10 is 8.4. How far did the decimal place have to go? 2, 3, 4, 5 places. 8.4 times 10 to the 5 will be our answer. Work that thing out in standard form. You could do it straight into your calculator. I'm going to show the non-calculator way just because sometimes the powers will be too large for your calculator to deal with. 6 divided by 8 gives 0.75. The powers, remember your laws of indices, we subtract the powers. 7 minus 2 takes us to 9. In standard form, we have to choose 7.5. We made the first bit 10 times bigger, so we make the power 10 times smaller. Subtract 1 from the power. 7.5 times 10 to the 8th. And your calculator will give the same answer. We have our compound interest question. We have 150,000. It's depreciating. It's going down by 18%. Start with 100, lose 18 is 0.82 as our multiplier. And we're doing that for 3 years. So we'll put to a power of 3. Typing that into our calculator. Careful I didn't typo there. It looked close for a moment. 82705.2, but it wanted it to the nearest euro, so I'm not going to put the 0.2 in. 82,000 after 3 years. We have a curve. We have a line. Our line is always y equals mx plus c, so we need to work out those two things. C is where you cross the y-axis, -1, and our gradient, if we draw ourselves a little triangle, is our change in y, which is -2, divided by a change in x, so our m is just -2, -2 divided by 1. So that's y equals -2x minus 1. And you could, if you wanted, to sub in a random value and check it works. If I sub in x equals 1 into this, I do get y equals -3, and indeed x equals 1, y equals -3 is indeed a coordinate. So you can have a tap on our backs for that. Question 12. A bit of trig coming in finally. We want to find the length of AB, but in the triangle that AB is in, at least a right angle triangle ABD, we only know one thing. So we need another thing to work out first, and it looks like BD would be that helpful thing. So in BCD, let's try and write correctly. In triangle BCD, we have the hypotenuse and we have the opposite. So that's sine of 32 is equal to the opposite over the hypotenuse. So y is 3.1 sine 32. Typing that into my calculator gives me an answer of 1.64, etc. And now when I use that y again, I'm going to use the answer function in my calculator, so I don't lose any accuracy and I don't need to write out a ridiculous number of decimal places. In ABD, well, now I have a different setup. We now have the hypotenuse, but this time we have the adjacent. That y is now the adjacent in that triangle. So this time it's going to be cos. Cos of 42 is equal to the adjacent, which is at 1.64, over the x. Now either multiply up by the x, divide by the cos, or know that the trick is just to swap the cos and the x. And now in my calculator, I'm going to do answer over cos 42, giving me 2.21, etc. The question wanted it to 3 sig fig, so 2.21 is what I'm going to quote on the answer line. It is also worth, in these kind of questions, is just checking, does that answer seem reasonable? The only other length we had was 3.1, so 2 point something does seem quite reasonable, definitely, as AB does look a little shorter than BC. Question 13, cumulative frequency. Careful, we've already been given the cumulative frequency, so you don't need to actually work that out here. We just need to plot it. The key thing about cumulative frequency is we plot the end point against that cumulative frequency. So I'm going to plot at 40, I should have a height of 6. At 50, I'm going up to a frequency of 20. At 60, I'm now up at 56. At 70, 84. Notice I've spotted that each little square goes up in 2s. Probably the first thing you should have spotted. 95 is our first odd number. Let's just check I'm on the right place. Yep, at 80, I'm going to 95, which is perfectly between the 90 and the 100. And then finally at 90, I'm plotting up at 100. Now I could, doesn't gain you extra credit, but I could also plot 0, 30, or 30, 0, because we know there's no data less than 30. So now, again, yours will look better than mine because yours is pencil and paper, whereas on the iPad it's often much more difficult to draw that nice smooth curve. Part B, use your graph to estimate the median length that they went for a walk. Well, the median is halfway up. We know there are 100 adults, so the median is going to be at 50. Of course, the answer is not 50. We need to go across and down on our picture. Please do draw on those markings. That counts as your working. And if we read off the scale at the bottom, it is 58. Notice 2 marks. One of those marks is for doing a sensible line on your diagram. One of the 100 adults is chosen. We want to try and use the graph to estimate the probability he went for a walk for more than 72 minutes. Well, now 72 minutes is going to be on my bottom scale rather than on my vertical scale. So I'm going to start at my 72, and this time I'm going up and across. I'm trying to do it relatively level. Of course, it's not that easy. And I read that off as 86. Well, that doesn't mean that 86 took more than. That's saying that less than 72 minutes was 86 people. So more than 72, well, there are 100 people in total, was 14. As a probability, let's put it over the total, simplify it, and my answer is 7 over 50. Question 14, some index work now. Here we need to remember the fact that a power to a power is multiplying the powers. So I've got a power of 12 multiplied by 3/4, so it's now going to be x to the power of 9. Y to the power of 8 to the power of 3/4, 8 times 3/4 is 6. So x to the 9, y to the 6 is our answer. Part B is quite a tricky one for two reasons. One, there's lots of letters. We want n in terms of x and y, but also notice that that y is not on a 3. So our first thing we need to do is notice that 9 is 3 squared. Change the base so they're all the same. And now power to a power on the denominator. And dividing means we subtract powers, gives us n is x minus y, minus 2y. Quite a tricky question, but once you've mastered change a base, very quick marks. Our circle theorem question. A, B and C are points on a circle with the centre. Already I'm seeing various shapes. I can see the arrowhead here. I might use that in a second. AOC is a diameter. Well, that tells me things about right angles. Might use that in a bit. Work out the angle DBC. So I need this little bit of an angle here. Well, actually, the two things we've just mentioned are exactly what is needed. Careful though, it does give the giver reason. So every single number I wrote down, I need to justify. So let's use the AOC being the diameter first. So that's going to tell me that angle ABC is a right angle, as angles in a semicircle, I apologise for my writing, is 90 degrees. So that's telling us there that ABC is a right angle. Let's also use that arrowhead as well. That's saying that ABD is half of the 98 is 49, as the angle at the circumference is half the angle at the centre. You do need to know all those statements, at least the key words in the statement. They will look for the half or the double, angle at the circumference, angle at the centre kind of statements. Well, now we basically have everything we need, because now angle that we wanted, which was DBC, well, the whole of ABC was 90, ABD was 49, so the leftover is 41, and there is my answer, and I've given reasoning all the way through. You'll probably only get 2 marks for 41. The other 2 marks are for those reasons. And there's probably other ways to do that question. That's the way that I spotted first. I didn't talk about the staples this time, but we're definitely past the staples by now. So our questions are getting a bit more challenging. We have an inverse proportional question here. So that's saying inverse proportional to the square of x. That's saying that y equals k over x squared. Over because it's inverse, x squared because it's proportional to the square of x. Well, I need to find this k. This currently is a formula, but it's not complete. So I need to find the k. So I'm going to use 2,9. That looks like one of the nicest ones. So I'm going to sub in 2,9 into that. Y is 9. X is 2. Timesing up by the 2 squared, timesing up by 4, gives k equals 36. For my own mental well-being, I'm going to check in my calculator at least one more. If I do 36 divided by 1.5 squared, I get 16, which is the y value. I'm happy. On the answer line, I am going to write the formula, not just 36. 36 is not the formula. Part B. Given that x is greater than 0, find the value of x when y is 144. Well, we have our formula. Let's replace the y with 144. So I'm trying to solve 144 equals 36 over x squared. Multiplying up by x squared, dividing through by the 144, Notice this was a similar trick that we had with the cos much earlier in the paper. And x comes out the square root of a quarter, which should be plus or minus a half, but we were told that x was positive, so my solution is just x equals 0.5, or 1 over 2. Always worth noticing why a question has said something. Question 17. We give information about the first 6 terms of a sequence. Prove algebraically that the sum of any 2 consecutive terms is always a square number. This looks like quite a challenging question. And if you are ahead of the game, you might notice these as the triangle numbers. Now, the first thing we need to do to be able to prove is to have a general formula. So if we're trying to work out how does 1 turn into 1 times 2 over 2, how's 2 turn into 2 times 3 over 2, it looks like it's always over 2. It looks like the term number times by the next number, n times n plus 1. And you can check that pattern works all the way across. So we need to prove that 2 consecutive terms, that'll be un plus 1, that whatever this is, turns out to be a square number. So here we just need to do some algebra. Well, un is exactly what we've just written, over 2. Un plus 1 we need to be a bit careful with, because both the n turns into n plus 1, and the n plus 1 turns into n plus 2. This looks like I need to do some factorizing and simplifying. I'm going to put everything over 2, I've got that common denominator already, and expand out my numerator. N squared plus 3n plus 2. I foiled quite quickly on the top. Simplify the top. I'm not going to try and skip any steps, even though I might be able to see where this is going. I'm not going to cheat. A very common error now is, how do we deal with this fraction? We have the common 2. We need to divide each and every part by 2. Well, n squared plus 2n plus 1, we should notice, is just n plus 1 squared. So what have we shown? We've shown that un plus 1 is n squared, n plus 1 squared is a square number. Now, proof questions, we should always write a concluding statement. Therefore, the sum of 2 consecutive terms, and I'm just rewording the question, is a square number. Question asked us to prove that result. I've done some work, and then I've said, hey look, I've proved the result. Question 18, functions. Functions are given by that and that. State which value of x must be excluded from any domain of f. Domain is what goes in. I'm never allowed to divide by 0, so I cannot have that 4x minus 3 equals 0, so I have to exclude x equals 3/4. That's what will make that expression 0. fg of x, well, fg of x means f of g of x, so I'm going to put g, x minus 5, into f. Everywhere I saw an x in f, I've replaced it with x minus 5. A little bit of simplification. As so. And finally, for our functions, we want f inverse. Trick here is to set it y equals. And then we're going to try and rearrange to make y the subject. I'm going to multiply up by the denominator. I should really put the extra line of working in where I haven't expanded the bracket out yet. I'm trying to get that now x equals, so I'm going to bring the x over and 3y back, factorize the x, and finally divide. So my function f inverse of x is, well, I need to replace the x with the y. So instead of being 3y, it's 3x over 4x minus 1. Some people prefer to swap x and y right at the beginning. It doesn't matter if you swap it at the beginning or the end, you get the same result. Question 18 done. Oh, not question 18 done. We have part D of the question. Part of the curve y equals h of x, we haven't been introduced to h yet, is shown. Find an estimate for the gradient at -1/2. So we want to try and find the gradient at this point here. Now you need to remember that the gradient of a curve is the gradient of the tangent at that curve. I'm not convinced by that. And this is why you should always draw in pencil on your graphs. I'm even less convinced by that. And it'll be much easier for you on pen and paper. So that's going to be my rough gradient. You do get quite a lot of leniency with this. And I'm going to pick a triangle. I'm going to go to there. And that looks good enough. So my change in y, each little square in my y is going up in 1, so I think that's a change of 8. And my change in x is going to be a little bit more difficult, but it looks like each little square is 0.1. So I think that comes out about 1.2. It is positive, so my gradient is going to be roughly my change in y. Don't need a roughly and an equal sign. Be roughly the change in y over the change in x. 8 divided by the 1.2, which my calculator's given me as 20/3. It was over in the estimate. It doesn't tell me to round it to anything. I am gonna turn it into a decimal and give it to 3 sig fig, just because it's going to be a range of answers anyway that they'll be looking for. And it's easier to check for the examiner in decimal rather than fractional form. Now question 18 is done. Question 19, we have a sector. We have the sector OAPB of a circle. AB is a chord, the angle is, the area of the sector is that. Work out the perimeter of that shaded segment. Okay, well, one thing we can see we're missing immediately is the radius. Now we remember that the area of a sector is the angle over 360 times pi r squared, and it's been helpfully given to us that that is 25/2. The only missing thing in this equation is r. We know that the 80 degrees is our theta. So 80/360, I'm going to cancel the pi's, r squared equals 25/2. I'm going to divide by whatever 80/360 is. I'm not even going to work that out, I'm going to just type into divide by 80/360. That gives me 225/4. That makes me happy because that is a square number. Both the numerator and denominator are squares. The square root of that comes out as 7.5 centimeters. So I now have the radius. The question asks for the perimeter of the shaded region, so I need both the arc and the AB. Let's do the arc first. The arc length formula is theta/360 times by the entire circumference. So that's going to be 80/360 times 2 pi times 7.5. Typing that into my calculator. I'm going to leave out the pi for now, and I type it in to give me 10/3 pi. So that's going to be the curvy bit of my picture. So I've done the curved AB. Now I want to find the actual AB. Now that is in a triangle where we know 2 of the sides and we're missing the last. So that's a cosine rule question. AB squared equals A squared plus B squared minus 2BC cos A. Again, carefully typing that into my calculator. I'm going to get AB squared is 92.96, etc. So AB is the square root of that. It's 9.64 ... Does that seem reasonable? Yes. That angle should be bigger than the 7.5s. It shouldn't be ridiculously bigger, but 9.5 is 9.6 is the right kind of bigger to 7.5. So now the perimeter is AB plus the arc. I can use the answer function because I still got that 9.464 dot in my calculator. I'm adding on the exact answer before, 10/3 pi. So the exact answer is now stored in my calculator, and I can round it as required on the answer line to 3 sig fig. 20.1 is my answer. Question 20, bounds. As soon as I see bounds, my instinct is to work out the upper and lower for the two things. To 3 sig fig, my upper and lower are as follows. To 1 decimal place for B, 6.25 and 6.35. Now we actually wanted the upper bound for the value of x. So we need to pick whether we're using the upper or lower bounds for each section. If I want to make this as big as possible, I want to use the upper bound on the top. I want to make the top as big as possible, whereas I want to make the bottom as small as possible. Well, to make the denominator small, I need to choose B to be as small as possible, and also subtract off the biggest possible A. That's convenient because now we're using the same bound for A on the top and the bottom. Let's make sure I get A and B the right way around. 6 lots of the upper bound over the lower bound of B minus the upper bound of A. I'm doing an excessive amount of working because I know this is what the examiner needs to see. If I type something into my calculator and I mistype, which is very easy to do, I only want to lose at most 1 mark. Whereas if I wrote out, let's actually write out a few more decimal cases because this one rounds weird. If I just wrote my answer rounded poorly, I would lose a lot more marks than if I'd wrote all this working. Give your answer to 3 sig fig, 7.46. And notice I almost made exactly that mistake there. If I'd misrounded this to 7.47 with no working, I'm unlikely to get any marks at all. With this working, I would only lose 1. Question 20 is done. Question 21, another similarity question. Bottle A has surface, bottle B has surface area and volume. So this is going to be that mix between the different scale factors. The area scale factor is what we have enough information for. Big divided by small. The area scale factor is 9/4. I can't use 9/4 for the volumes because I need the volume scale factor. So to get there, I need to get to the length scale factor, which is the square root of the area scale factor. And then the volume scale factor is the length scale factor cubed, 27/8. Now that was our scale factor to go from the small to the big. I always use small to big for me. So if I wanted the volume of bottle A, well, my volume of bottle B, but I need to make it smaller, so I'm dividing by that scale factor rather than multiplying by it. So that 20,025 divided by that gives an answer of 600. That is a really nice looking answer. Chances are I've done it correctly. 21 done. Question 22. A really nasty complete the square. I know it's complete the square because I see that form there with the completed square. The real difficult thing about this one is that negative in front of the x squared. So The first step, whenever you have something in front of the x squared, is to factor whatever that thing is. We have to factor out -2 here. Do that carefully. And I'm also reordering the x squared and the x in my bracket. Then I can complete the square. X minus 6, we halve the thing in front of the x to put in the bracket, subtract off that thing squared. Notice I've kept these square brackets around with that -2. I'm now going to expand out those big square brackets. That -2 has to hit the bracket and hit the -9. One of the easy ways to make the mistake is making that -18. We do have a negative going on. Finally, collect together the stuff. And we're left with 23 minus 2, x minus 3 squared. That is in the correct form. It is okay that both the b and the c are negative. We're told they were integers, not whole numbers, not positive whole numbers. 22 is done. 4 marks, quite generous if you can perfect that technique. Question 23. We have a solid pyramid. The base is a square, so I'm going to add in another 10 centimeters over here. The vertex A is above the center, so that all of the slanted lengths are the same. The total surface area, okay, I wasn't sure where this question was going, but that's quite harsh. The total surface area is 360 centimeters squared. And we want to find out the angle between AC and the base. So our final step is probably going to be using that triangle AOC. Before we do that, we don't know AO. We could work out OC fairly easily, but we'll do that later. AO is going to be the problem. Now, the only thing we've been told is the total surface area. Well, the total surface area is made up of the base and 4 of those slanted triangles. The base we can work out is 100 plus 4 triangles is 360. So the area of one triangle, 360, subtract 100 divided by 4. Each triangle has an area of 65. Okay. Well, what can I work out about one of these triangles then? At the moment, I'm just trying to work out everything I possibly can. It has a base of 10. The area is 65. Well, that means I can work out the height fairly easily. So the height of one of these triangles, well, half base times height equals 65. So a half times the height times by 10 is 65. So the height of one of these is 13. Okay, so that height there is 13 centimeters. I'm going to give that a name there, just so that I can keep referring to it. I'm going to call it M for midpoint. Well, that's kind of useful. If I complete the triangle going AOM, and OM is 5 centimeters halfway across that square base, I have another right angle triangle. So let's have a look at that one. Every time I use a triangle, I'm going to redraw it. I know the slanted height is 13. I know the side on the bottom is 5. How tall is it? Well, that's a Pythagoras. So AO squared plus 5 squared equals 13 squared. 13 squared minus 5 squared. So AO is 12 centimeters. And if you have done a lot of practice, you might recognize the 5, 12, 13 as a Pythagorean triangle. Quite a common one that they do like to use. Okay, so I've got OAO. Well, now if we remember way back to the start, we wanted AO so that I could use the triangle AOC. Okay, because that gives me the angle I want. The angle AC and the base is exactly that angle there. Well, I haven't found OC yet, so I need to go back and find OC. Well, OC's best triangle is probably OMC. So O to M to C, O to M is 5, M to C is 5. We want to try and find the longest side. Another Pythagoras, 5 squared plus 5 squared equals OC squared. So that's equal to 50. OC typed into our calculator, or just a bit of surd work, comes out as 5 root 2. Okay, well now I can finally go to that red triangle. That red triangle AOC. OC was 5 root 2. OA is 12. And we want the angle ACO. Well, then that's the opposite and the adjacent. Let's give that the name. So tan is what we're using. Tan of opposite over adjacent. Tan inverse of that in my calculator. Tan inverse of 12 over 5 root 2 gives me an answer of 59.491, etc. The question wanted to 3 sig fig, so 59.5. And notice that I did use that space quite efficiently. You did have an entire another page worth of working space if you needed it. 6 marks? Yeah, 6 marks for this question. Very justified, a very challenging, long question. And notice we didn't really have a plan for this question. We just had to use whatever was given in the only sensible way each time, and eventually it did fall out. Question 24, and we see the total marks at the bottom. This is our very last question of the paper. We have a box of marbles. 4 are red, the rest are yellow. Straight away my mind has gone to, this is going to be an algebraic tree question. We're going to take a marble and not replace it. Sergio is then going to take another marble. The probability they both take yellow is 0.7. Now I am a keen tree user, so I'm going to draw out the tree. You could probably do it without. I'm going to use it. So you're going to have Antonia and Sergei picking out their marbles. I'm going to say that there are X yellow marbles to start with. I think that might give the cleanest looking maths. Of course, you could have chosen there to be X in total rather than X yellow, both of which will lead to the correct answer. So for the first pick, we have 4 red marbles. There are X plus 4 in total, and there are X yellow marbles out of X plus 4. Notice those 2 branches do have to add up to 1, and indeed they do. If I pick out a red, I only have 3 red left, and I've lost 1 from the total as well. If I picked out a red, I still have X yellows, but now only out of X plus 3. Again, notice that those do add up to 1. If I picked out a yellow, I still have 4 red. Oops. But I only have X plus 3 in total, not X plus 4. And if I picked out a yellow, I've got X minus 1 yellows out of X plus 3. Again, check your numerators do add up to the denominator. We've been told that the probability they both take a yellow is 0.7. Well, that's what gives me my equation. X over X plus 4 multiplied by X minus 1 over X plus 3, because I multiply across my tree, is 0.7. That's my equation I need to try and solve. Well, I'm going to clear up the denominators first. I'm imagining that as 7 over 10, so I'm going to multiply up by 10, combine the numerators on that side, and I'm also going to multiply up by the denominators of the left, so they appear on the right. Expanding out brackets, I'm recognizing this is likely to be a quadratic equation, So I'm now considering, how do I solve quadratics? Well, I need to get them equal to 0. Well, to get there, I need to expand everything out first. I'm hoping that I can refactorize afterwards. And now I can bring everything to the same side. 3x squared minus 59x. This isn't looking hopeful. Minus 84 equals 0. Now, I'm a big fan of factorizing, but that factorization looks incredibly challenging. I'm going to spend roughly 20 seconds just thinking about it, seeing if I can spot how 84 should split, but I'm not going to waste too much time. I don't see how that'll factorize easily and quickly. Even using the split in the middle method is going to be too challenging. So I'm now going to go straight to the quadratic formula. Quadratic formula is negative b plus or minus the square root of b squared. Notice I've dropped the negative sign because I'm squaring it. Minus 4 lots of a c. I'll need that negative sign though. All over 2a. Now I am desperately hoping that one of these two solutions is a whole number. If we think about what x was the number of yellow beads, tokens. Well, if that's not a whole number, then I've done something wrong with my algebra. Now my two solutions with the positive sign does come out as 21, which is really a good sign. And with the negative 9 is negative 4/3. I'm going to reject the negative 4/3. That makes no sense for my problem. And I'm going to quote, so x is the number of yellow. So the number of yellow was 21. The question wanted how many were originally in the box. Add on the 4 red. There were 25 marbles in the box. And I could actually use those to go back to see what the factorization was, but I don't think I was spotting that horrendous of a factorization. That is the end of the paper. Of course, you would go back through, check all your working, look for any silly errors, fill in any gaps that you may have had, but I'm going to stop there. As always, if you do spot an error with these or you have further questions, please do ask. Otherwise, enjoy.